So in the full semester, students have to do this, but there's not enough time in the summer. So I decided to get you through this one. So this is a freebie, right? 2% of your grade or 3% of your grade, whatever, right? Okay, so let me bring that homework up here. I put due date 7/2, but I mean I'm giving you the solution, right? So that shouldn't be a big deal. Okay, so let me. So it should be available for everyone. So let me go here, go to assignment, and let me bring it over here.
Would it be due on Tuesday the 5th so we can have our July 4th weekend?
I'm giving you the answer now.
Oh, sorry.
Like, why would
Um,
that's like wanting to ride and wanting to drive, right? So I'm gonna give you the solution. So if so just type along, right? So okay, so first we'll talk about uh, what we're trying to do, right? So we're gonna create a tic-tac-toe game. I do caution you, like whatever it asks you for in all the different assignments, just do that. You know, don't add your own flavor or whatever. Just whatever it's asking you for, just do that. Why? Well, it makes it easier for me to grade, but more importantly, when you're out there working, especially if you're working like for a bottom line driven company, they don't want you to worry about the bells and whistles. Like what they ask you for, that's all they want. Even if you have like good ideas, I can make it better like this. No, we just want the program to be good enough, right? Later on, if there's time, if there's budget, then we can add the latest and greatest features, whatever, right? So always like keep that in mind when you get an assignment, not here, not just here, but anywhere, like just what they're asking you for, then just do that. Okay. So here, like we're going to create the classic tic-tac-toe game. This iteration or this version of the game simply places X's and O's onto the board. We do not determine who wins. We do not determine if it's a tie. All we want to do is we want to create the class that allows us to place X's and O's on the board. And once we put 9 of them, right, once the board is full, then at that time we consider this iteration of the game complete, right? So if I just alternate like, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, the board is full, then that's it. The game is over, okay? We're not going to add code in this version to determine who won. That'll be in the next homework. Okay, right, so create a tic-tac-toe board data structure, check for game over. When is the game over? When the board is full. Clear the tic-tac-toe game for tic-tac-toe board for each game, and display the tic-tac-toe board to screen, right? So that's what we're wanting to do. It's recording down here. So, okay, so we have some instructions here, right, that we want to follow. But before we get started, we're going to create a vector, but I want to, let's see, where's the vectors? Tic-tac-toe vector, okay? So we're going to create a vector of 9 empty spots, okay? I think there's spaces, right? So let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9. That should be enough, right? So assuming this is the, I think I'll just say vector here, right? The vector, and say it started at this address here, y 196, 94, whatever, right? Addresses, and then over here index. Okay, so this would be in index 0, 1, 2, 3, 4, 5, 6, 7, 8, because there's in our board there's 9 slots, right? So we're not going to create some crazy two-dimensional array or two-dimensional list. We're just going to go simple. We're going to create a simple array that holds values here, right? So this might be x, o, x, o, x, o, x, o, x. Okay, so in our game, we do not want to expose the user to this sequencing, right? Because users are not programmers and they're not used to saying that position 0, position 1 is 0. Position 1 is 1 and it'll always be 1 to them, right? What am I talking about? Users see it like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. We are starting at index 0, but to the user it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So when we ask the user for a position, we just have to remember to deduct 1 from the position, right? So when we run into that piece of code, then this is the reason we're doing it, okay? And we work with a vector because they're easy to work with. Okay, so let's come back here. Okay, so let's create a Tic Tac Toe class. Okay, so let's create a Tic Tac Toe class. So we go here, and let me check this in. References and pointers. Okay. And then we'll go ahead and jump to homework. And we'll start with Tic Tac Toe Header. Okay. First thing, we want to take care of the header guards, right? So Tic Tac Toe Header. And then we want to define it if it doesn't exist, and then let's not forget end if. Okay. Okay. Now we create the class Tic Tac Toe semicolon. Okay, so we have that piece. And then let's see what the instructions are asking for. Okay, create a public function, right? So plus is public, so create a public function that returns a boolean, right, true or false. We name it game over. Okay, so let's go do that. So we create public and private. For now, that's all we need. Okay, bool game over. Okay, and then we jump to the CPP, and the CPP will write some code for this function. Okay, so include Tic Tac Toe Header. We write code for this function. Let's not forget to make it part of our class. So there we go. For now, we return false for now, okay? Because we need some other class functions to make this work. But for now, we'll just say, let me return false. Okay, so make sure you're following along, right? Because then this will be an easy assignment for you. So I'll display header for like a little bit, make sure everyone has that piece. And then the CPP, this is what we have so far. For now, we purposely return false, okay? And once you see the test case and the test case fail, the test case will guide us, right? The test case will guide us because we'll be like, hey, wait a minute, like this function is failing, so we got to make it pass. So then to make it pass, we just have to write enough code to make it pass, okay? So let me go find the test case. Include Tic Tac Toe Header. Test case, test game over class function. So we say Tic Tac Toe game, and then require that okay, so why this way? We want the test cases to guide us, right? So we know, I mean, it's going to fail because I am purposely returning false, but I'll still run it, okay? So run in terminal. Okay, let me see here. Oh, game over. Game.game over, right? So game.game over. And let's run it. Okay, so it's thinking. And it's still thinking, and well, it failed, right? Why did it fail? Because for our game over, we are returning false. And we're doing that because right now we don't have any logic in our game to determine if the game is over or not, right? But at least we have this test case. So notice as we are writing our class functions, we're writing the test case for that function, right? So we want good quality on our code, so that's why we do that. Okay, so let's see what we can tackle here, right? So to determine if the game is over or not, then we need to start the game, right? So then we go in here and notice it's saying create a void function start game that has a string first player. Okay, so let's create that piece. So I'm going back to the Tic Tac Toe header. And I have to remember to include string. Okay, so let's include string. And then I say start game, and I prefix string with std or stat : okay? And I think this one, we can write the code here because it'll only be one liner, one state. Well, actually, no, it'll be more than one statement. So semicolon at the end, Control C. Now we will jump onto the CPP to write the function for start game. the class function. So Tic Tac Toe CPP. Not forget to make this part our class, right? So Tic Tac Toe, scope resolution, start game. Okay, so we should be okay there. And now let's see what it's asking us to do on the right side, right? So we go here, first player function argument value must be x, and function set player to first player function argument. Call the clearboard function. Doesn't exist yet. Clearboard doesn't exist yet, right? But we can set the private. We can set first player to some new variable, right? That we don't have yet in private. So let's go look at our private data. So player, right? So player. So we need to create in private the string player. Okay, so let me go back here. Let me go back to the header, and I go to private, and I say string player. Okay, so Tic Tac Toe CPP. The private variable player is equal to whatever we receive as a parameter when we start the game, first player. Okay, so here we're just saying if x is the first player, then set player to x. If it's O, then set it to O. Okay, so I'm not sure what I meant with set to x. I think we're gonna first player function argument value must be x, or I think I said x or O, right? But okay, so everybody's following along so far, hopefully. Okay.
Yeah, I am.
Okay, so then I mean, this is a freebie, right? So then we go here, and since it's asking us to use clearboard, then maybe let's write the clearboard function, right? So clearboard, and let's go look for it. And it appears that clearboard is private. Okay, and no parameters, set all elements to a space, and we can't make it const, right, because we're going to modify data. So let's go here, copy. Keep on doing that. Okay, so clearboard, it cannot be const, because remember, const means read only. And what are we doing?
Didn't you say that it was private?
Yeah, I said it was private. Okay,
private. But you just put it in the public.
Well, that's a mistake on my part. Okay, so clearboard, and then what is clearboard doing? Set all 9 elements. Hey, wait a minute, what 9 elements? Oh, well, we need to add a vector, right? Because that's what's going to hold the logic to our game, or the data to our game. So we have vector of string pegs. Okay, so vector of string pegs. Okay, vector of string pegs. Okay, so let's include vector at the top. Vector. And then we say, okay, let's create a vector of string, and we name it pegs, and then we say create 9 elements with the value space, right? So remember, the curly braces initialize, so that's what we want to do here, initialize to 9 spaces. Okay. So now we can go back into our clear board and write some code to clear the board. Okay, so it's saying set all 9 elements to a quote space quote, right? So meaning to a space. Okay, so we have to go write some code for that. So let me copy the function signature and jump to the CPP. and I'll just say private functions here, and then we'll say Tic Tac Toe clearboard, right? So now we make clearboard part of the Tic Tac Toe class. Okay, so we can create a loop, right? So for auto reference, remember reference is the key in for range loops that allows us to access the elements directly. Peg in pegs, if you want to read it as English, for each peg in pegs, right? Do something. And then we say peg equals to quote, space, quote, semicolon. So we clear the board, okay? So that clears the board. Okay, so now let's go back to start game. So set player private variable to first player. Okay, we did that. Call the clearboard function. Okay, call the clearboard function. We haven't done that. So start game, and then it's saying to call clearboard. Okay, so we call clearboard. Okay, and then we go to the next function, which is mark board, right? So it's saying mark board, number one, mark vector with position -1 equals to player, right? So here we need to use indexing, right? So we'll use indexing, and whatever position we get from the user, we'll deduct 1, and then we'll get the value of player and assign it to that element. And remember, when we use indexing, we are accessing elements directly, so we will be modifying the vector's elements. Call set next player, private function. We don't have that yet, okay? But let's go ahead and do what we can. Mark vector with position -1 equals to player. Okay, so we need to create that function. Okay, so it's copy. Okay. So mark board. It's not const because we will be modifying data, and then we jump to the CPP. I think mark board is public. Yeah. Okay, so we're good there, and we can define it here. Open close curly brace, and let's not forget to make it part of the class. So the vector is pegs, right? So it's saying pegs position -1 equals to the private variable player. And then we need to call set next player. We don't have that function created yet, so we have to create it. Okay. So let's create set next player. So it's probably defined down here as private, right? So it's private. So set next player. If player variable equals X, set player O else X. Okay, so let's create that logic. Go to the header and private. Set next player. In the private access specifier, we go to the CPP. Set next player, open close curly brace. Make it part of the Tic Tac Toe class. Tic Tac Toe scope resolution operator, scope operator. Okay, so it's saying that if player is X, then Now the next player's turn will be Y. Else player is X, right? Because then it's Y, right? So player equals X. So now we define that function. And we have to call it in the mark board, right? So let's go to mark board, and then we say call set next player.
Can you go back down for a second? I didn't finish getting what was for the player X, Y portion. Okay, I'm good.
Okay, so we got that piece, and then in mark board we call set next player. Okay, so we mark the board, and we just need to set next player, right? Because as we're marking board, we're just keeping track of who's next. Okay. Okay, so string, public function string get player returns the player value. So this one is const, right? So get player, and it is public. So we say player const. Let's not forget start string at the beginning and the header. And this one we can simply write return player here, since it's just one statement, right? So we do it on the header. So there'll be no get player on the CPP. And that's it for this function, get player. So let's go back and display board const iterate vector of string pegs to display a tic-tac-toe board in 3x3 format. Okay. Okay, so let's write this piece here, Control C. Display board, and we have to write the code in the CPP because it'll be more than one line. And
I got a quick question. So on my side, on the if indef portion, it's saying that the end if for this directive is missing. I'm just gonna go for it after that. So just in case it is terrible.
or if not this piece, you mean?
Yeah, like right there where it's defining that on my if indef portion, it's saying that the
Well,
and yeah, it's saying the end if for this directive is missing. Did I miss something so far? I don't think I did.
no. No, if not def, define, and then end if at the bottom. Make sure you have a semicolon here. But right now I'll just keep on trucking, right? Because I can't because then I'll never finish if I try to help everyone.
Yeah, that's fine.
Okay. So where was I? Display board. So we go to the CPP, and we do that. Let's make it part of Tic Tac Toe display board. Okay, so display board. Okay, so we want to display something like this with cout statements, right? And we have a vector. Okay, so let me see. For integer I equal 0. I less than pegs dot size, right? Because we want to iterate every single one of them, okay? And then we if we do I plus plus, okay, let's go back and look at this piece here. Okay, so maybe if we say I plus equal 3, right? So let's go back and look at this. So I is 0. I is 0 here, and then we can say I plus 1, I plus 2, I plus 3. Okay, and then we loop again. So now I is 3 plus 1 plus 2 plus 3. And then we loop again. I is 6 plus 1 plus 2 plus 3. And then I guess we can tackle it like that. Okay, so let's see here. We need IOStream, right? IOStream. And I'm pretty sure I'll be using cout a couple of times. So I'll say using stud cout. Okay. I come back to display board. Okay, so we're like, okay, cout. Okay, so cout pegs at I, and then we do a pipe, and then pegs at I plus 1, and then another pipe, and then we do pegs at I plus 2, and new line character. Okay, so let's make sure this logic's correct. So I is 0, and we're indexing with 0. So 0, 1, 2. So if we say cout 0, then it outputs this one. If we say cout I plus 1, then it'll display this one, which is index 1. And if we say cout I plus 2, then it'll display this one, which is 2, right? So indexing with programmer indexing 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's why we're using this, right? So I plus 1, I plus 2. Comes back, loops, so now I is 3, 0, 1, 2, 3, so I'll display this one, and then I plus 1, 4, I plus 2, 5. So that should work. Questions there? Okay, so let's go on to the next one. Checkboard, right? So this is what's gonna eventually turn that game over from false to true. So we have to go through all that trouble. Okay. So now we go back into our header, and we have another private function, check board full. Check board full. Let me double check. Yeah, so this one is not void. This one should be BOOL. Boolean, right? So the logic here, let's check the vector. If all the values are if all the values are not a space, then that means no, if we have one space, right? If we have one space available, then the game's not over yet. Remember, the game here in our version is just to make sure that all the 9 slots have an X or an O. So we need to loop and look for a space. If we find the space, we return false because the game's not over. But if we go through all the elements and we do not find a space, then we know that the game is over. Okay, so that's what we're trying to do here. So let's make it part of our class. Actually, this is private, right? So let me move it down here. And you don't have to do this. This is just for our eyes. Okay, so Tic Tac Toe check board full. Okay. So then we can say for integer I equals 0, I less than the pegs dot size I plus plus. Okay, so if pegs at I equals a space, return false, right? Because the board's not full, we found the space. Outside of the loop, right? So make sure that you write this statement outside of the loop. We say return true, return true, meaning if we exited, if we checked every single element and we didn't find the space, then we know that it's full with X's and O's. So the game, in essence, the board is in essence full. Okay, so we got this piece. In the game over function, we are returning false. So we will change that to return check board full. Okay, so we go back here to game over. And instead we'll say return check board full. So if the game is full, then the game is over. If it's not full, then the game is not over yet. Okay, so that's the thinking here. And is that it? Clear board, check board, send next player, display board, get player, mark board, start game, game over. Well, the truth is in the test case, right? So, okay, so let's go to our test case and create an instance of a tic-tac-toe game. We did call the start game function, X or O, it doesn't matter, right? Call mark board 9 times using numbers 1 to 9. This test case will eventually be the test case for CAT, or call it a tie. So this is the positions we want to call in sequence, right? 1, 2, 3, 4, 5, 7, 6, 9, 8. That generates a tie, okay? Once you have, next week, once you have the logic for who wins, this test case will convert to the call it a tie test case. But for now, it's just, is the game over? We have to write all that code to come over here, and maybe we say test if the board is full, okay? But we'll also be checking if it detects false game overs, okay? So what's the thinking here? Okay, we can say, okay, so without thinking of programming, right, to check if the game is full, to play the game in this iteration, we have to mark every single board with X or O, every single board position. So we start marking it, okay? So we say game dot mark board 1, okay? After each marked board, we want to make sure that we check if the game is over. Why? Because we want to make sure that our logic works as expected. We don't want to mark board 9 times and then check game over at the end, because then in essence the game might have ended like after position 3, and we don't know, right? And or maybe it's not supposed to end at position 3 and it ended, so that means our logic is flawed. Okay, so here we say require that game over is false, right? Because the board is not full. So in essence, it should still be a valid game. So then we're like, okay, so let's mark the board with position 2. And then again, the board should not be full, so game over is false. Make sure you do this for all the test cases, right? Some students, for some reason, they never listen to me. Like in the next week's test cases, make sure that after every marked board, you always check for game over, just to make sure that you don't have false positives. And then we call with position 3, and the game should still not be over. And then we call with position 4, and the game should still not be over. And then we call with position 5, should still not be over. Let me get the sequence. 1, 2, 3, 4, 5, 7, 6, 9, 8. Okay. So the next one is 7. So 7, and still not full. 6, still not full. 9, still not full. And then finally mark it with position 8, and after position 8, check a board full should return true, because we've exhausted all the available positions. Okay, so as I was explaining in the test case, I put them out of sequence because this test case will convert to the call it a tie test case once you have the logic for who wins in the next homework. Okay, so I haven't even tried to compile, so let me do a sanity check and let me compile the library first to make sure that that piece works. And it doesn't, so let me see. Pegs. Let me see here. Okay, so that's a warning. That's a warning. Oh, okay, so here I invert the semicolon should be after player. Okay, so let me go fix that. Right here, right? So it should be semicolon, and then we remove the semicolon outside the curly brace, right? Because this is a statement, and statements need to have a semicolon at the end. So let me go back and build a library. Okay, so that's a warning. So notice that it's warning us, and anytime you iterate a string or a vector, you'll get this warning that that we're using an integer to compare against a long unsigned integer. So an integer supports negative numbers and it supports positive numbers. A long unsigned integer only supports positive numbers. So an integer goes up to 2 billion, 2.1 billion. So now if the unsigned integer only supports positive numbers, then it'll be twice as big. So it'll go up to 4 billion. So that's the issue we have here in our loops, and that's why it's warning us, right? So I'm not gonna change the code. I guess we can change it, right? Yeah, you can loop through assertions. Yeah. Okay, so let me see. So it's warning us here, right? So let me go show you. Right here, it's saying that that size at one point will be larger than an integer, because size is of long unsigned integer, right? So if we want to, we can fix it. Let me remember that piece. What is it? Start, forgot the syntax for that. I guess we can say long unsigned integer. And where else are we using a loop? Unisigned, okay. Okay, so let me build. Again, this is semantics, right? But notice now I don't have the warning because now I'm comparing two data types that are the same. Okay, so, well, there's a special type that you use, but I forgot. But this works, okay? Notice the warning is gone, so that's good. So now we go back to our test case, and then we maybe give it a spin, see what it brings back. It's beautiful green, right? So we're good. So our logic works, right? So this test case, as we were marking the board, didn't detect a false game over. So a false positive meaning. So not until we exhausted all the positions did it return game over true. So we're good. So meaning now we can jump onto our main program and let's see what it's asking for. Prompt the user for first player, start the game in a user control loop, prompt the user for a position, and call the markboard Tic Tac Toe class member function. Okay, so let's see how we do that. Main include Tic Tac Toe Header. Include, I guess iostream was in the header, but I'll still include it here. Using start cout, using start cin. Okay, so let's play a game, right? So we say Tic Tac Toe game. Okay, so we create a game. Okay, so we'll do while something. Okay, so notice I didn't prompt you to validate or anything, right? So right now we're assuming our users are perfect. And I do that because I want students to focus on the class concepts and not on validation, which you can go to YouTube, to Google and figure out that stuff, right? So, okay, so we need, we also need string, right? So include string. Using string, I guess player, or first player maybe, first player. Okay, cout, enter, first player, capture input or character input, cin, first player. Okay, so once we have the player, who's going to be first, why does this happen? The mouse is too sensitive. Okay. So once we have the first player, then the next step is to start the game. Okay. Okay, so game, start, game, first player. Okay, so we start the game. Now we need a variable position, and that's what the user is going to give us, okay? Okay, so while game over, so maybe, well, not game over, right? Well, not game over. Well, not game over. See out, enter a position. So again, I didn't specify to validate if they're going to give you a position from 1 through 9. So for now, we just assume our users are perfect, okay? I think later on I do ask, in the next assignments, I do ask like to come back and add validation. So C in position. So we get the position. And once we get the position, then we say game dot mark board, right? So we mark board with position. And this will continue until the use. Okay, so maybe we call display board, right? So mark board. Okay, and let me see here. Enter position, mark position. I guess here I call game dot display board because we want to show the user like what's going on, right? And we're gonna keep on asking them until the game is over. Okay, so once the game is over, then we want to ask them if they want to continue, right? So okay, so while user choice equals yes, or user choice equals capital yes, right? Capital Y. Okay, meaning here we have to ask the user, right? Play again, right? So play again. And capture input, user choice. Okay, so as long as they say yes, right, so as long as they say yes, then it'll continue. Once they type anything else, I won't. Okay, so okay, so let's review this. So we create an instance of game. We create a string first player, character user choice, cout, enter first player, capture the first player, start the game, game.start game, first player, variable position, loop while the game is not over, enter a position, capture the position, call mark board, display board, and ask them if they want to play again. That's choice, right? So here I'm saying play again, enter Y or Y, right? So I mean that's developer preference. or whatever the requirements are that are given to you. In my case, I just said, I'm going to use Y, and that's it. Okay, so let's see what happens here, right? So we go to CMake, and we go to SRC, and we go to homework, Tic Tac Toe, and let's try to run it. Enter first player. Enter position 1. Enter position 2. Why? Why? What happened there? Why? Oh, I think I did put Y. Let me see here. Yeah, I put Y instead of O. Right, so that's why it's a Y. I'll fix that. Okay, so 3, 4, 5, 6, 7, 8, 9. Play again, enter Y or Y. Right, so enter first player. I guess I'll put X again. I gotta fix that logic, right? Enter a position 9. Right, so yeah, good. I'm gonna exit, Control C. Let me go and fix this piece here. This has to be O. I don't know why I put Y. Okay, so now it should work. So that's homework 5. Right, so it's a freebie for you all, but notice that it's a lot, right? So one thing from now on is I do put students under pressure with the homeworks, but remember, you can collaborate with each other, right? Collaborate.
Can you tell me why my if in def statement it says the directive is missing?
Hold on. Let me finish the lecture, right? So then I can help students troubleshoot. So again, the homeworks from now on are going to be, they're difficult, right? But that exposes you to what you're going to see out there. You're not going to go to a job and they're not going to baby you. I mean, they're going to give you training, and then they're going to expect you to be a contributor. So the next 3-4 weeks, while homeworks are difficult, you can collaborate. You can stop by my office. I can guide you, Monday through Thursday, right, 5 to 6. Don't spend hours and not progress, right? If you spend 1 hour and you're stuck, my advice to you is stop, come to the office hour, or go to the online channels that you all communicate on and try to get help from someone. Post on the boards, come to my office hour, because that's not how programming works, right? Like, you don't go to a job and spend 8 hours stuck and then tell your boss, like, I didn't get to do much because I'm stuck, right? No, once you're stuck, and then you go ask for help. So the same thing applies here. And do not be embarrassed to ask for help, right? Everybody's here to learn. Programmers that have 10, 15, 20 years experience ask other programmers for help, right? And that's how work is done. Okay, so I will. So how many of you all were able to complete the program and run it successfully?
I was.
Matt, you were able to?
Yeah.
Okay. Got it.
I literally only have like 2 issues. So the if in def statement on mine is coming up missing, or like it's saying that it's missing.